We made it to Friday! Hey guys, welcome back to another episode of Life Noggin. Today, we're going to be talking about... So, if you think you know everything about this topic, go ahead and put your knowledge to the test in the comments section below. See if you can stump us. If you want to learn more, go ahead and check out the information provided below. But first, what is new heights? Well, in astronomy, a new height is the apparent shift in the position of an object when observed from different locations. It's also known as parallax, and it's what astronomers use to measure distances to nearby stars. Now, just to clarify, when we say an object is shifting, we don't mean that it's actually moving. We're just saying that it looks like it's moving because we're looking at it from a different perspective. Think of it like when you hold your finger in front of your face and close one eye. Then you switch which eye you're looking with. Your finger appears to jump across your visual field. That's because your brain is trying to process the difference between the two perspectives. But really, your finger isn't actually moving at all. It's just staying still while you look at it from two different angles. The same thing happens with the stars. But since we're looking at them from different points in Earth's orbit around the sun, instead of just a few miles like with your finger, these shifts can span hundreds of astronomical units. And by measuring these shifts, we can calculate exactly how far away the star is. This is called the parallax method, and it's one of the most accurate ways to measure distances in space. Now, let's talk about how this works in a little more detail. Let's say we have a star that is relatively close to us, and we want to figure out how far away it is. First, we need to find the baseline of our measurement, which is basically the distance between the 2 points that we're observing the star from. Since we're on Earth, the best baseline we've got is the diameter of Earth's orbit, which is about 300 million kilometers. So, we observe the star from Earth at one point in its orbit, and then again 6 months later, when Earth is on the opposite side of the sun. At this point, we have 2 data points for the position of the star, and we can use trigonometry to calculate the distance to it. The angle between the 2 data points is called the parallax angle, and it's measured in arc. 1 arcsecond is equal to 1/3600th of a degree, or approximately 4.85 kilometers. So, if the parallax angle is 1 arcsecond, then the distance to the star is about 300 million times that, or about 1.4 trillion kilometers. For comparison, that's about 1/4 the distance to Proxima Centauri, the closest star to the sun. Now, this method only works for relatively nearby stars. As the star gets farther away, the parallax angle gets smaller and smaller until it's too small to measure. The most distant star whose parallax we have measured is probably around 1,000 light years away. Beyond that distance, other methods become more practical. But we will talk about those other methods in another episode. So now it's time for some space for thought. How do you think astronomers are able to measure such tiny angles? Well, it turns out they're able to do this thanks to some extremely precise telescopes, including the Hubble Space Telescope. In fact, one of the main reasons why Hubble is still operational after all these years is because of its high precision. In addition to advancing our understanding of the universe, Hubble has also enabled astronomers to make incredibly precise measurements of nearby stars and other objects in space. These measurements have allowed us to map out the structure of our galaxy in unprecedented detail and have helped us to better understand the nature of dark matter and dark energy. So not only has Hubble advanced our understanding of the universe, but it has also had a profound impact on our ability to explore the depths of space. So that is just a quick overview of new heights and how it is used to measure distances in space. If you want to learn more, go ahead and check out the information provided below. As always, this has been Life Noggin. Don't forget to keep on thinking.